do one simple thing. Listen carefully to every single word. I guarantee 80 to 90% of this topic will be ready in your mind right now. Physics is actually very easy.
Vector product, properties of vector product. In last lecture, we studied scalar product. Now we will study vector product. Both scalar product and vector product have same theory, almost same. For example, if we replace this vector with scalar and this vector with scalar, then this becomes the definition of scalar product. Now it is a definition of vector product. If we replace this vector with scalar, this vector with scalar, then it becomes a definition of scalar product. Similarly, Hoare theory, a few words change, especially the properties of vector product and scalar product are same and very important, because short questions, MCQs, and as well as long question comes from these properties in the paper. So must understand these properties rather than just memorizing. Let's begin. Just try to understand, I'm repeating, try to understand rather than just memorizing. Let's begin. Vector product. Product means multiplication here in simple words. Vector. Vector means having magnitude and direction. Let's quickly recall the concept of vector and scalar. A simple example that you can remember. 4 markers in my hand. I have 4 markers in my hand. It's the first example. Look here. N is equal to 4 markers. N is equal to 4 markers. N represents the number of markers. 4 marker is equal to. Another example. Another example, I apply a force on this duster in this way. I'm repeating, second example. If I apply a force on this duster, in this direction, and the force is, for example, 6 Newton. The force is applied, 6 Newton force is applied on this duster. Second example, F is equal to 6 Newton force n unit vector. N unit vector represents the direction. Look here. 6 Newton is the magnitude. N unit vector, this n unit vector is the direction, and direction in this way because the force is applied in this way. Look here, I'm repeating. Force is applied in this way, not this way, not this way. Force is applied this way. So the direction is this way. This n represents the direction, which is in this way. And 6 Newton is the force. 6 Newton is the force which I applied on this duster. So n unit vector, this is the direction and this is the magnitude. Both magnitude and direction, it means force is a vector quantity. Force is a vector quantity. Vector has both magnitude and direction. So force is a vector quantity. This is a scalar quantity because it has magnitude only, no direction, only magnitude. This is the magnitude. This is the magnitude and this is the direction. N number of markers is equal to 4 markers. These 4 markers has no direction. So no n unit vector, it's a scalar quantity. This force has magnitude and direction. So a vector has magnitude as well as direction. So the force is a vector quantity, n is a scalar quantity. Now graphical representation of a vector. Graphical representation of this force. 6 Newton force. So draw a 6 centimeter line. For example, this is a 6 centimeter line. And put an arrow in this way. 6 centimeter line. This 6 centimeter line represents the magnitude. The length 6 centimeter represents the magnitude, which is 6 Newton. Arrow shows the direction, which is in this way. So this is the graphical representation of this force. Similar to this, we have another vector A and a vector B making an angle theta with each other. Here we revised the concept of vector and scalar. This revision will help you to understand this property or this vector product. Now come to the definition. This is the definition of vector product. For the better understanding to the definition, look here at this example first. Torque is equal to R cross F. As we know that force is a vector quantity. Look here. Force is a vector quantity. Force is a vector quantity. Moment arm is also a vector quantity. Torque is a vector quantity as well. Force is a vector quantity. Torque is a moment arm is a vector quantity. Torque is a vector quantity. Multiplication of two vectors. This is a vector, this is a vector. Multiplication. Multiplication means product. Product means multiplication. Both are same. Multiplication of vectors or product of vectors. When product of vectors gives a vector, it is also a vector. Product of vectors gives a vector. When product of two vectors gives a vector, then the product is called vector product. Very simple definition of vector product. Then the product is called vector product. Look here. When multiplication of vector or when product of two vectors gives a vector, when the product of two vectors gives a vector, then the product is called vector product. It's the definition of vector product. Hope you got it. Now, it is represented by cross between two vectors. Cross between two vectors. A cross between two vectors. Force is a vector, moment arm is a vector. Cross between two vectors. Cross between two vectors. It is represented by cross between two vectors. Formula. This is the formula for the cross product. A cross B is equal to AB sine theta n unit vector. N unit vector is because it is a vector product and vector has direction. Scalar has no direction, then there will be no unit vector in scalar product, which we already studied in the previous lecture. Where AB is the magnitude. AB, magnitudes of the vectors. Theta is the angle between vector A and B. Look here. This is theta. Theta is the angle between vector A and vector B. Theta is the angle between vector A and vector B. Theta, angle between vector A and vector B. N, as you know that N is the direction. Look here. N is the direction and this N is in this direction, but this N is the perpendicular to both A and B. Look here how. we can find the direction of A cross B by using right hand rule. What is right hand rule? Very simple. Right hand rule, not left hand, right hand. Right hand rule, but rotate the fingers of your right hand from first vector A cross B. A cross B, A is the first, B is the second. Put the finger in the direction of first vector, rotate them in the direction of second vector. Then the erect thumb will show the direction of A cross B. I'm repeating the right hand rule. Pay attention. Put the fingers of your right hand in the direction of first vector. Curl them in the direction of second vector. Then erect thumb will show the direction of A cross B, which is perpendicular to both A and B. So, and direction perpendicular to both vector A and vector B. Look here at the definition. Rotate the fingers of your right hand from first vector to the second vector. Rotate the fingers of your right hand from first vector to the second vector. Look here, through this smaller angle, what does it mean? We have two angles here. One is this and the other. This is smaller angle, this is larger angle. So through the smaller angle, not through the, this is through smaller angle and this is through larger angle. So don't rotate through the larger angle. The right hand rule is through the smaller angle, then the erect thumb will give the direction of, the direction of A cross B, or give the direction of the cross product. Hope you got the right hand rule. And this, as we know the example, another example. This is the second example. This torque is equal to R cross F. This is the first example of vector product. This is second example. Movement arm, product of Mason velocity, is a vector quantity. Position vector is a vector quantity, and angular momentum is also a vector quantity. So product of two vectors gives a vector. So it is an example of cross product. Now come here. Consider two vectors A and B. Consider two vectors A and B making an angle theta. Making an angle theta with each other. Then the direction of A cross B. This is very important, or this is a key point. Listen carefully, very easy and very important. These properties depends on especially the first property. Depends on this concept. So pay attention here. Then the direction of A cross B. The direction of A cross B is out of the board. Direction of A cross B is the out of the board, and direction of B cross A is the into the board. This is the out of the board, this is the into the board. Into the board. Okay. How? Look here. A cross B. First vector is A, second is B. Here, first vector is B, second is A. First, here apply the right hand rule on this A cross B. Put the fingers in the direction of first, rotate them in the second. The direction is out of the board. Something that coming out of the board. Now look at B cross A. B is the first, so put the fingers in the direction from first vector, in the direction of first vector. First vector is B. Curl them in the direction of second vector. Then this erect thumb will show the direction which is into the board, something going into the board. So B cross A is into the board, A cross B is the out of the board, into the board. B cross A is into the board, A cross B is out of the board. Both are in opposite direction. Right hand rule we already studied. Now one is represented by N, out of the board is taken as positive n, then into the board will be negative n. One is positive, then opposite direction. N unit vector represents the direction. Now look at the first property, properties of vector product. It is not commutative. Now look at what does it mean. First, look here, what is first property? What is commutative property or commutative law? In simple words, 2 multiplied by 3 is equal to 3 multiplied by 2. 2 multiplied by 3, 6. 3 multiplied by 2, 6. Both are equal. 2, 3, 6. 3, 2, 6. Both are equal. This is commutative property in simple and easy words. 2 multiplied by 3, 6. 3 multiplied by 2, 2, 3 and 3, 2. Both are equal. Both are 6. Both are equal. This is commutative property. But this is not commutative because 2, 3 and 3, 2. AB and BA are not equal. That's why it is not commutative. This is commutative. But this is not commutative because AB and BA are not equal. One is out of the board, other is into the board. So AB and BA are not equal. So first property, the cross product is not commutative, but it is anti-commutative. What does it mean? Anti mean both are in opposite direction. One is into the board, other is out of the board. So they are anti-commutative. AB is not equal to BA. A cross B is not equal to B cross A, but is equal to minus B cross A. Minus shows both are in opposite direction. One is into the board, other is out of the board. This minus represents both are in opposite, means both are anti-commutative. This is first property. And direction reverses when order change. Here AB, now order change. BA, direction is reversed. First out, then into. Here direction reverses when order change. Magnitude remains equal. Magnitudes remain equal. How? What does it mean? For example, the magnitude of A cross B is 8. I'll change the marker. For example, the magnitude of A cross B is 8, then the magnitude of B cross will also be 8. But the direction will be opposite. One will be into the other will be out of the board. But the magnitude will remain the same. Magnitudes remain equal in both cases. Only direction reverses. This is the first property from here to here. Now second property. Cross product of two parallel or anti-parallel vectors is a null vector. What does it mean? These are anti-parallel. Now angle between anti-parallel is 180. Second property. This is the first property. Now second property. In second property, and first we will discuss anti-parallel, then parallel. Angle between anti-parallel is 180. 180 degree. Look here. These two are anti-parallel. The angle between two anti-parallel vector is angle between two anti-parallel vector is 180. Now angle decreases. Here angle is 90, decreases 50, 30, 10, 5, 0. Now they are parallel. Angle between two parallel vector is 0, and between two anti-parallel vector is 180. Now first we will discuss 180. Then A cross B is equal to AB sine theta and unit vector. This is the formula. Look here. A cross B is equal to AB sine theta and unit vector. But in antiparallel, theta becomes 180. Look here. A cross B is equal to AB sine theta and unit vector. Theta is 180 between antiparallel vectors. Now A cross B as it is, theta as it is, AB as it is. Now sine 180 is 0. You can check by using your calculator. Sine 180 is equal to 0. You can verify on your calculator. And unit vector as it is. Now again A cross B as it is, AB multiplied by 0 is equal to 0. Anything multiplied by 0 becomes 0. So 0 and unit vector as it is. Now focus here. Look at 0 magnitude direction. So 0 magnitude direction, it is a 0 vector or a null vector. This direction is arbitrary direction. This is known as 0 magnitude and direction. So it is a 0 vector or a null vector. So A cross B, between cross product of anti-parallel vector is a null vector or a 0 vector. Look here, is null vector. Cross product of two parallel or anti-parallel vector is a null vector. Now for 180, same for two parallel vectors. 180, 90 decreases 10, 5 and 0. Now they are parallel. Both vectors are parallel. Now for parallel vectors, vector A and vector B. Now they are parallel. Angle between two parallel vectors is 0. Again A cross B is equal to AB sine 0. For parallel vector, sine is, angle is 0. And unit vector as it is. Now A cross B as it is equal to as it is, AB as it is, sine 0 is equal to 0. Verify by using your calculator. And unit vector as it is. Again A cross B as it is equal to as it is, AB multiplied by 0, 0. Anything multiplied by 0 becomes 0. And unit vector as it is. Again 0 magnitude with direction, it becomes 0 vector or a null vector. So in both cases, null vector, null vector. In case of antiparallel 180, in case of parallel 0. Cross product becomes a null vector, a 0 vector. This is the second property. Cross product of two parallel, this, or antiparallel, this vector is null vector, null vector. Now look here. Look here. Cross product with itself. Cross product with itself is also a null vector. What does it mean? Cross product with itself is also a null vector. What does it mean? Cross product of a vector A with itself. So vector with itself, no angle means 0 angle. For example, cross product of this vector with itself. So both are same, 0 angle. So again, A cross B is equal to AA sine 0. If AB then AB. If AA then AA. Angle 0 with itself 0. AA sine theta and unit vector. This is a basic formula. Now A cross A as it is equal to as it is. AA as it is, sine 0 is equal to 0 and unit vector as it is. Type sine 0 on your calculator, you will get 0. A cross B as it is, AA multiplied by 0 is equal to 0 and unit vector, here it's a 0 vector or also known as null vector. So cross product of a vector with itself is a null vector. Here it's proved. Cross product of with itself is also a null vector. it becomes as a short question in the paper. Prove that cross product of cross product with itself, cross product of a vector with itself is a null vector. Prove that. So in answers you have to write from here to here. It's proved. Similar to these properties, a short question may come. Prove that the cross product of two parallel or anti-parallel vector is a null vector. So to prove, you have to specially write these mathematical steps in answer from here to here. Now similar to this, for unit vectors, we have three unit vectors I, j, k. Look here. X-axis I unit vector, y-axis j unit vector, x-axis, y-axis, and this is the z-axis, and k unit vector is along z-axis. This is the z-axis and k is along z-axis. I, j, k, x, y, z. So k is along z-axis. Now I cross I means cross product with itself. With itself is 0. So I cross I is 0 vector or null vector. J cross product with itself. So cross product with itself is a null vector. So it's a null vector or 0 vector. K cross K again with itself. So it's a null vector or 0 vector. Now third property. Cross product of two perpendicular vectors. Here anti-parallel, parallel. Now in third we will study perpendicular. This is the third property. Third property is for two perpendicular vectors. Between two perpendicular, the angle is 90 degree. These two are perpendicular. The angle between two perpendicular vector is 90 degree. Angle between two anti-parallel vector is 180. Angle between two parallel is 0. So here we will have to study perpendicular. The angle between two perpendicular vector is 90 degree. Now look here, 90 degree. A cross B for perpendicular, angle 90. A cross B, AB sine theta, theta is 90 degree for perpendicular vectors. AB as it is, equal to as it is, AB as it is, sine 90 is equal to 1. You can verify. Type sine 90 on your calculator, you will get 1 and unit vector as it is. Now again A cross B as it is, equal to as it is, AB multiplied by 1, AB and unit vector as it is. Now focus here. Cross product of two perpendicular vectors is maximum. This is the maximum value. You can also write cross product of two perpendicular vector is equal to the product of or multiplication of their magnitudes. This is the magnitude of vector A, this is the magnitude of vector B, and they both are multiplying. The product of their magnitudes or multiplication of their magnitudes. I am repeating, this is important. Cross product of two perpendicular vector is equal to product of their magnitude. Product means multiplication. Multiplication of their magnitudes or the product of their magnitudes. Or you can write is maximum. This is the maximum value also. Now, similar for unit vectors. Focus here. For unit vectors, you have to apply right hand rule. I cross j. Put this is the I, this is the j, and this is the k. This is the k. I, J, K, X, Y, Z. This is the Z. This is the X, this is the Y, and this is the Z. And this is I, this J, and this is the K. This is the K. Now, look here. I cross J. Put the fingers of your right hand in the direction of I, in the direction of first vector. Curl them in the direction of second. This is the second J. I, J. It becomes a K. And K is in this way. I cross J becomes K. So I cross J is equal to K. Now look here. J cross K. J cross K. Look here. J cross K. This is the K. J cross K becomes I. Put the fingers in the direction of J and curl them in the direction of K. This is the J. This is the K. Curl them in the direction of K. It becomes I is equal to I. Look at this. K cross I. This is the K. This is the I. K cross I. Put the fingers in the direction of K. K, curl them in the direction of I. It becomes J. So these are the unit vectors by using right hand rule. Now the fourth property is cross product in terms of their rectangular component. Cross product in terms of their rectangular components. Look here. In 2 or 3 lectures back, we studied the rectangular components of a vector. In that lecture, we studied vector A in terms of rectangular components is AX I unit vector plus AY J unit vector. Similarly, we studied in that lecture that vector B in terms of their rectangular component is Bx I unit vector plus By J unit vector. This we learned in 2 or 3 lectures back. Must go through that lecture for better understanding of this property. I will put the link of this lecture in the description. This is in 2D. In 2D, vector A has 2 components along x-axis and along y-axis, rectangular component. In 3D, it also has a component AY, AZ, K unit vector in 3D. X, Y, Z, I, J, K. Similarly, X, Y, and Z. This is in 2D now. In 2D. But in 3D, a BZ also comes here. K unit vector. In simple, these are the rectangular components of B. Bx, By, Bz, X, Y, Z, I, J, K. B is equal to this, A is equal to this. Now come here. A cross B is equal to, put the value of A here, X, Y, Z, I, J, K, these value, this value of A here, then cross as it is, then B. Now by putting the value of B, this value here, X, Y, Z, I, J, K, cross it. Now we have to multiply these both. A simple way to multiply these both is the determinant. By using determinant, we can easily multiply these both. How? A cross B as it is equal to as it is by using determinant. IJK, IJK. AX, AY, AZ, AX, AY, AZ. BX, BY, BZ, BX, BY, BZ. This is in determinate form. Now look here, how to multiply A cross B as it is, equal to as it is. Now by using determinate rules, write I here and ignore this line and this line. Ignore this and this. These four are left here. These four are left here. Now cross product. AY AZ, AY AZ minus AZ BY, AZ BY. Close the bracket. Then write minus. Now write J here and skip this line and this line. These both. Write J and skip the lines of J, this line and this line. These two and these two are left. Again cross multiplication of this and this. AX BZ, AX BZ, then minus AZ BX, AZ BX. Close the bracket, plus now write K here again. Now skip the line of K's, lines of K. This line of K and this line of K. These four are left here. Again cross multiplication, this and this. AX BY, AX BY, AY BX, AY BX, write minus. Hope you got it. Now look here. Within bracket minus, within bracket minus, within bracket minus. It's a rule of determinant. Now another plus minus, plus minus, plus minus. This is a rule. First one is plus, second one is minus. Then plus, then minus, then plus, then minus. Within bracket there will always be minus. You can simplify a little bit more, but it's enough for here. Now physical significance of cross product. What does it mean? Physical significance of a cross product. Pay attention. As we can find the area of this square or parallelogram, this parallelogram for example. How? By multiplying its length with width. To find the area of this room, we will multiply the length of the room with the width of the room. We will get this whole area. So to find the area, we have to multiply length with width. Length of width, we will get the whole area of this parallelogram or this box. To find the area of this parallelogram, for example, consider this is vector A and this is vector B. So by multiplying length with width or by multiplying A cross B, we will get both the area of this parallelogram. So the area gives the magnitude of the cross product. If we find A, this is A, this is B, A cross B or length multiplied by width, both are same almost. The magnitude of the cross product give the area of parallelogram in simple way. I am not going in deep here. So area is equal to magnitude of A cross B and no direction. Direction is normal to the area or plane. Normal to this area or this plane. How? Put the fingers in the direction of A, call them B. This is normal. This direction is normal to this area, this direction is normal to this plane. So direction is the normal to area or normal to the plane. Hope you got it and enough for the today.